All right, today we're going to be looking at graphing linear inequalities in two variables. So a linear inequality in two variables, x and y, can be written as ax plus by less than c, ax plus by is less than or equal to c, ax plus by is greater than c, or ax plus by is greater than or equal to c. It's important to know what each of these are, what these inequalities are. So is less than, is that symbol, is less than or equal to, looks like that, is greater than, and is greater than or equal to, looks like that. So if it's in this form of ax plus by, which we consider our standard form, we use this form if we're just going to identify if an ordered pair is part of a solution, if it's a solution to that inequality. However, when graphing, it becomes more difficult when it's in standard form. So we're going to look at some steps in order to graph our linear inequalities to help us solve inequalities as well. But anytime they're asking if an ordered pair makes an inequality true or if it's part of the solution, we're going to do more of this in class. We're going to be practicing more in this class. So what we're looking for here is we're looking to be able to graph this like we normally do in slope-intercept form. So in order to do this, we're going to follow these steps. First step, we're going to solve for y. So we want to put this in slope-intercept form. Y equals mx plus b. Now, really, really important, something you want to remember, if you multiply or divide both sides by a negative number, when you're solving for y, then you must flip the inequality sign. This is huge. Anytime you're solving an inequality, if you ever multiply or divide both sides by a negative, then you must flip the inequality sign. A less than becomes a greater than. A greater than or equal to becomes a less than or equal to. It's really, really important. If you miss that step, you will get incorrect answers. Next, to graph, we're going to plot the y-intercept. That's our starting point. And I want to plot at least two other points using the slope. Where the slope tells you from that starting point where you go up, down, left, or right. Next, and 3 and 4 are interchangeable. It doesn't matter which you do first. We want to determine if the line is going to be solid or dashed or dotted. You'll see some places where it says dotted, some where it says dashed. It does not matter to me. And then we also need to determine if you are shading above or below that line. Now, you cannot use these steps unless you solve for y. Determining if a line is solid or dashed and above or below only works if it is in slope-intercept form. So that's why step number 1 is extremely important. So, how do I know when we have a solid line or a dashed line? Well, what comes into play here is what the symbol looks like. The easiest way I remember solid line is that my inequality has a solid line underneath it. So if we see a greater than or equal to, or a less than or equal to, that means we're going to have a solid line, which means we can include any point on that line as a possible solution. A dashed line will have no solid line underneath it. So anytime you see just less than or just greater than, we're not going to be doing a solid line. We're going to be drawing a dashed line, and then we'll shade above or below that. Shading above or below here, if we have greater than or equal to, that tells me I'm going to be shading above this line. Now there is an exception. If we have a vertical line, we cannot shade above a vertical line or below a vertical line. This has to do with left or right. Well, if I want greater than on a number line, that's to the right. So if we have a vertical line, we're going to shade to the right. Again, that's a special situation when we have a vertical line. Shading below will be less than or equal to. And just like before, we also have our special case. If we have a vertical line, we shade to the left. It's a vertical line. So again, following the steps, we need to make sure that we are in slope-intercept form, y equals mx plus b. If not, when we're solving for y, don't forget that rule. If we multiply or divide those sides by a negative, we've got to flip that inequality sign. Next, we're going to identify the slope and the y-intercept, so that helps us plot our points, and then we can determine if we have a solid or dashed line and if we're shading above or below. So for example, if we look at these three inequalities, if we look at all of these inequalities, notice that they are all in slope-intercept form already. So we don't have to worry about solving for y here. We're already at y equals mx plus b. I can identify my slope and my y-intercept right away. So my y-intercept is that plus 3, that b. My slope is just the 2. Don't forget, slope does not include the x. The slope is the m value in front of the x. And I can rewrite 2 as 2 over 1. This will help me with my rise and my run. I can either go up 2 or 1 and 1 to the right, or I can go down 2 and 1 to the left. Don't forget that whenever you have a positive, they can either both be positives, the 2 and the 1, or the 2 and the 1 can both be negatives, because a negative divided by negative is a positive. So starting with so we have a y-intercept, we have a slope. Now we can identify if we have solid or dashed. Well, looking at our inequality, less than, and I look up here on top, solid or dashed, it's going to be a dashed line. And my shading, since it's less than, is going to be below. So when I graph this, I'm going to start, remember that y-intercept is our starting point. And according to step number 2, we first plot our y-intercept. So at 3, and like I said, at least 2 points, just to kind of make sure our line is straight. I'm going to go up 2, and then 1 to the right. So there's 1 point, or I can go down 2, and 1 to the right. Notice that right here we're going to have you can kind of see that line for me. We have a dashed line, so I'm just going to dash. Like this. And if you want to do more points, you can kind of see when you draw more points, if you just continue that pattern, down 2, 1 to the left, down 2, 1 to the left, you can see your line a lot better. So it is dashed. Don't forget the arrows, because that line keeps on going. And we want to shade below. So I'm going to shade below this, which is down here. Now, if you're ever unsure, and so we're going to practice more of in class, you can always check a point in the shaded region. The easiest one to pick here to check would be 0, 0. That's one I like to check for mostly all of them, just to make sure I've either shaded correctly. So I'm going to pick 0, 0 as my ordered pair, and I'm going to plug that into my original inequality. So this says that 0 is less than 2 times 0 plus 3. So if I solve this, 2 times 0 is 0, plus 3 is 3. Is this a true statement? 0 less than 3? Yes, that is true, which means I've shaded in the correct direction. Any point on that shaded region is going to make my inequality true. Now, what happens when we get something where it's not solved for y? So first thing we have to do, we need to solve for y. We need to put that in slope-intercept form. So remember, we need to isolate this negative 2y. So we want to leave that by itself. So that means we need to get rid of this 3x. So to get rid of the whole thing, we subtract the whole thing to the other side. Use a different color. So subtract 3x to the other side. If it helps you to just kind of draw a little line down the inequality so you keep things balanced, you're more than welcome to. We have a negative 2y less than, I'm going to put my x first, and then plus 10. So negative 3x plus 10. And then my last step here, I want to leave that y by itself, so I need to divide both sides by negative 2. Now this is where, because we're dividing by negative, this sign needs to flip. We need to flip that sign. If we don't flip that sign, the whole inequality is incorrect. Our graph is going to be incorrect, so we need to be very careful. So this is going to be y greater than these two negatives turn into a positive. 3 halves x. Please leave your slopes in fraction form. It makes it easier to graph. And then 10 divided by negative 2 is negative 5. Now that we have slope-intercept form, I'm going to identify my slope of 3 halves. This tells me I'm going to go up 3 or 2 to the right, or down 3 and 2 to the left. My y-intercept is a negative 5. Again, this is our starting point. Shading, looking at my inequality, it's greater than, there's no line underneath it, so this is going to be dashed. Actually, this is above. We're looking at shading above. Dotted and solid is below here. So this one is dashed. And now it says dotted. If you want to write dotted, you're more than welcome to. Shading, because it's greater than, we're going to go above. All right, so I'm going to start graphing this. So your starting point is negative 5 on my y-axis, because that's my y-intercept. And I can't go down, so I'm only going to be able to go up here, because I can't go down 3. So I'm going to go up 3, 1, 2, 3, 2 to the right, 1, 2. There's our next point. And again, I like just to do as many points as possible. You only need, I say 2 to 3 points, but I like to go as far as I can if it fits on my graph. It just makes it easier to look at. Oops, I deleted too many. Here we go. So I know that it's dashed, so just going to do little dashes in between those points. Here are my arrows, and I am shading above. So above. And again, if you want to check some points to make sure that you're correct, I like to pick that 0, 0 here. So I'm going to plug it, and you can plug this into your original or into your new one. I sometimes like to plug into my original just in case to make sure that my graph is correct, because if I made a mistake somewhere along my solving for y, then of course it's going to come out to be true. So I'm going to go back to my original. 3 times 0 minus 2 times 0, is that less than 10? Well, 3 times 0 is 0. 2 times 0 is 0. 0 minus 0 is 0. And is 0 less than 10? Yes, it checks out, which means I have shaded in the correct spot. We'll go ahead and look at one more. 3y is less than or equal to 4x minus 12. This is not in slope-intercept form. There's a 3 in front of my y, so I need to solve for y here. This is a little bit easier. We're just going to divide everything by 3. I did not divide by a -3, so my sign gets to stay the same. This is 4/3 x minus 4. My slope is a 4/3. My y-intercept is -4. Again, don't forget, that's my starting point. My 4/3, I can go up 4 and 3 to the right, or down 4 and 3 to the left. Looking at my inequality, less than or equal to, we're going to shade below, and my shading is going to be, my line is going to be a solid line. So starting at -4, I cannot go down 4 and 3 to the left, so I'm going to go up 4. 1, 2, 3, 4. And then 3 to the right. 1, 2, 3. And there is that. And then I can go up 1, 2, 3, 4. 1, 2, 3. There's another point. And then this is a solid line. Do my best here. Use a straight edge, a ruler, the edge of something, so that way your lines are straight. And we're going to be shading below. So, unlike before, where we tried 0, 0, because it was on the shaded part, if I try 0, 0, since it's not in the shaded part, it should give me a false statement. It should make my inequality not true. So if I do 3 times 0 is less than or equal to 4 times 0 minus 12. 4 times 0 is 0, minus 12 is -12. Is 0 less than -12? No. Which means I should not shade above, I shaded below, which is perfect. Now if that confuses you, then pick a point in the shaded region. It's just going to look a little bit different. So if I pick, let's say, 4, -1 here, and remember, any point in the shaded part. If I pick 4, -1, and I plug this in, so 3 times -1 is less than or equal to 4 times 4 minus 12. This is -3. 4 times 4 is 16, minus 12 is 4. Is -3 less than or equal to 4? Yes. So I know that I've shaded in the correct direction. So you can choose points either to prove that you've shaded correctly by it being a false statement, or picking something in the shaded region to prove that it's a true statement. We'll do a lot more practice in class. If you have any questions at the beginning of class, please make sure you have those ready.